Okay, I'm going to try to record number 8 from your test review. So you've got these three vectors coming through here, 12, 10, and 16 are their magnitudes. And then we've got an angle of 65 degrees over here, a right angle right up here at the top, and then the big angle going through here of 153 degrees all the way around. Now the problem is asking us to find the resultant vector to get from here back to here. So that's going to look like this right here, and we're supposed to find the magnitude of this first, and then we'll worry about the angle in a little bit. In order to do this, I need to figure out the components of this piece, and so I want a horizontal component of that line and also a vertical component. And if I have those two pieces, I could use Pythagorean theorem to figure out the length of the red part. So in order to do this, I've got to do kind of that same thing backwards for the vectors I do have. So I'm going to try to figure out, first of all, this angle up at the top. You can see initially they give it to us at 153. Well, I need to split it up. I know that I have a right angle, or I could take a right angle out of it anyway. If I split it like this, I've got a 90-degree angle up here at the top, and then that means 63 degrees are left over. And so now I can see that this will form some nice triangles for me to figure out horizontal and vertical components. So as I go through, I'll just draw these in. I've got the vertical component of this this vector of length 12, and then there's the horizontal component. The 10 in the middle, it just kind of goes straight across because there is no vertical piece to that at all. And then I've got another horizontal piece sticking out over here, and then I'll have to drop down for this last piece here. And this is where I start having to do math. I've got an angle of 65 degrees, and I have a hypotenuse of 12, and I'm interested right here in this adjacent side, the side adjacent to the 65. So if I think about SOHCAHTOA, the trig ratio that has the adjacent side in it is this one right here. And so that means I'm going to be using cosine to figure this piece out, just talking specifically about this one right here. So let me write this out for you, and we'll start with this 12 and then the cosine of 65. And then I'm going to continue that process for the other three pieces that I have on here. And now it's just a matter of putting those values into my calculator. And after I do that, I get these results. Notice that all of them are positive. Up is positive, to the right is positive, to the right is positive, until this one is negative, going downward. And then to put this together, the ones that are blue, they match up with this blue horizontal component, and the ones that are green match up with this green horizontal component here. So it'll look like this. And then the only thing that's tricky is when I get these results, I'm going to have to switch the signs because I've got my vectors are going back. I'm not truly adding the vectors. Like I'm not going from the base of the first all the way to the end of the last. I'm trying to figure out how do I get back. And so up here, where I've got this 14.3 minus 5.1, um, it's going to come out negative when I subtract it. but I'm going to know it's actually a positive value because my vector is going up. So that's going to be 9.2. And then on the bottom, I've got that 10.9 plus 10 plus the 7.3 to get 28.2 down there. And then it's just a matter of applying the Pythagorean theorem to get the red part. So that's going to be 28.2 squared plus 9.2 squared. And then I want to take the square root of that answer, and it comes out to be 29.662, but we'll just put 29.7 for us. Then the last piece is the angle theta that's described on your review as the angle from east. And so if I do an inverse tangent and if I use this 28.2 and this 9.2 to set up an inverse tangent, that's going to give me this angle right in here. But I want the angle, the way it's drawn on the sheet, I want this angle coming all the way around. So once I find this angle, if I call this angle theta, once I find this, I just need to do 180 minus theta. And that will give me that last piece over there. So remember that to find that, I'm going to use the tangent function. So that's going to be an inverse tangent of 9.2 divided by 28.2, which is 18 degrees, 18.1 degrees. So then remember that we're trying to figure out how to find one specific angle from east in the question on the review. And so if I subtract that from 180, I'll get 161.9. So those are my two answers, magnitude 29.7 and the angle is 161.9 degrees.